This is Office Hours,
the show for sharing experiences and stories in governance, risk management, and compliance.
Today, I'm excited to talk about something I've experienced recently in learning about machine learning. And I think that I have a pretty interesting way for our viewers to apply machine learning to risk management.
I think it's a great topic. It seems like I get asked almost every day in the role I'm required to carry out. Almost every day, it feels like we get asked somebody who's saying, oh, my CFO told me, asked me, how are we using machine learning? Or I was told by our board we have to be thinking about an AI strategy. Yeah. For every 10 questions I get like that, for every 100 questions I get like that, I might get one that is a practical question about an application of machine learning as a real tool. It's all just magic.
Yeah, because people are just scrambling to utilize these tools, but they don't actually know how they want to use them. They don't have a problem they're trying to solve.
Yeah, it's high on the hype cycle peak of promises and magic going to happen with very little practical application yet.
Right, but there are some really good tools out there, and I think there's really good practical application. You just need to understand the problem you're trying to solve, and if one of these tools is the right tool to solve that problem, that's when you want to incorporate AI or machine learning.
Right. If I'm Amazon.com, book reviews was the obvious place to apply machine learning. Dan, you bought this book, so next you should buy these 3 books, was a clear problem that we could actually apply this to. So it sounds like you're going to talk about a clear problem where you could take a machine learning tool and move that problem forward.
And that was actually a great example because Amazon uses similar machine learning that we're going to show today to provide those recommendations.
Right.
So we've said machine learning about 20 times already in the episode. It's only a couple minutes long. Maybe we should start it with what is machine learning for maybe people who are a little bit less technical. Dan, maybe you want to take a crack?
Not
How
really.
Would you?
No. The idea of machine learning, right, is fundamentally machine learning is about using algorithms that fundamentally complex math allows this algorithm to get smarter as you apply more and more data so that it can make better and better assumptions, predictions, outcomes.
Yeah, exactly. Machine learning is actually a subset of artificial intelligence.
Right.
And it mostly utilizes statistical algorithms in order to train the models and predict outcomes or provide outcomes for you.
Right. So, but, which I imagine you're about to show next, within what you just described, there's several different significant types.
Yeah, the biggest categorizations of machine learning out there right now are reinforcement learning, unsupervised learning, and supervised learning. Today, we're actually going to focus on unsupervised learning, which I think is really cool in that you don't really have to tell the algorithm anything about your data because you don't know anything. You're exploring the data and the machine is helping you explore it. And it takes all of the data that you feed it and it gives you back information and patterns it finds in the data.
So fundamentally, by way of background, for those that have watched before, you and I both come from a place of a lot of experience with sort of rules-based or visualization-based or pre-configured, I know the question I want to ask of data, which enough customers or enough organizations, I should say, struggle with as it is. This is a step forward from that, or perhaps even in some respects a step backward from that, to say if we don't yet know what to ask a specific set of data, but we know what the data is generally about, unsupervised learning lets me see there might be relationships in that data that are interesting that I hadn't preconceived of.
Yeah, exactly. Usually unsupervised learning will cluster your data for you or group it together in particular groups to say, hey, we found patterns in all the data you provided and all the fields you provided. We found patterns in these different groups within the data.
That's cool. I can understand that.
Supervised learning, which we'll actually do another episode on later, is when you provide, you basically label the data for the machine and it learns and can then label future data for you and group it to that previous labeled data. The easiest example that I can provide is around fraud. And so if we label, say we have 1 million transactions and we found 5 of them were fraud through some manual investigation, we can label those 5 transactions as fraud and all the rest of the million as not fraud, use that to train the model. And now every time new data comes in, it tries to recognize, is this transaction like one of those fraud ones? If yes, then flag that as potential fraud.
Or if I am the Walt Disney Company and I run Walt Disney Resorts and I saw, hey, out of 5 million, I have no idea how many people actually go to Walt Disney Resorts, but out of 5 million people who came to Disneyland, these 40,000 came back again a second time based on all this other data we have about where they stayed, what they bought, the tickets they had, whatever else, the time of year they came. Who amongst the 5 million that came this year are we likely to see return, and how can we drive that up, perhaps?
Yeah, that's another really good example.
Okay. No, that was off topic because we're talking about unsupervised learning.
Yeah, and then reinforcement learning is actually the category I honestly understand the least, so I'm probably going to say something stupid. But basically, you can program a machine to be able to make some decisions or take some actions based on what happens in order to optimize getting to a particular outcome, in order to provide a reward. So a very simple example is the bots that you encounter on the internet when you go to a website. It will try to coerce you into maybe wanting to buy something as quickly as possible. And depending on what you answer back, it will answer back to you differently and try to create an optimal path to you buying something.
Right. So what Amazon Alexa is trying to become.
Yes.
Okay.
But let's,
Off we go.
We're going to provide more examples in future episodes. But like I said, today we're going to talk a little bit more about unsupervised learning. Usually,
I do think this is the most interesting use case for most people I run into in risk management, particularly, frankly, because like it or not, as a profession, we're pretty bad at using data today if we were to honestly compare ourselves to marketers or to sales,
Right.
or arguably even to finance.
I think there's some really great use cases for supervised learning, but for sure, when you're exploring your data and you don't know much about it yet, unsupervised learning could give you some valuable insight that you're unable to get elsewhere.
Which we run into in risk management all the time.
Right. So this on the screen is the simplest version of data clustering that I can provide. There's just 2 dimensions to this data plotted on X and Y axis. And you can see on the left-hand side, that's the original unclustered data. It's not categorized. And then the clustered data on the right is clustered into red, blue, and blue, and green groups.
But I probably could have done that for you with a blue or with a green and a red pen.
Right. Yeah, pretty easy
So why
to
did I
do
need
when
your
you
fancy machine learning?
Yeah, pretty easy to do when you can visualize it on 2 dimensions. But imagine I have 10 dimensions or 20 dimensions or 100 dimensions. Are you going to be able to sit down with a pen and pencil and be able to figure out what the pattern is?
Right. So that's interesting, right? Because I see this massive migration of people towards thinking data visualization are analytics. This is debating terms, but this is exactly where this big trend towards data visualization is just sending us down a path of reinforcing things we already know, perhaps,
Yeah,
as opposed to uncovering things that we don't know.
exactly. So let's talk a little bit about, we're going to utilize a method that's one of the most popular methods for clustering data, called Kmeans clustering. And the reason why it's so popular is it's pretty simple for people to utilize and understand. I'm going to take you through the steps on how you can get there. And where I think there's a really interesting use case for risk management is in utilizing data to better understand behavior or business or customers or processes or departments. And what I mean by that is I hear all the time risk managers say, I'm expected to be an expert in every department in every part of the company.
Right.
But that's impossible.
Internal audit the same.
Yeah, internal audit the same. So you need to rely quite heavily on internal SMEs and internal experts to understand they're part of the business. But in doing that, when you're interviewing
Or
them,
hiring external consultants, yeah.
yeah, or that. But in doing that, you're really relying off the information that they give you, and you're making a lot of assumptions. So how could you possibly test some of those assumptions or validate those assumptions or maybe find new insights? I think taking data, whatever data is available, and using clustering in order to understand and explore the data and understand that department or process or customer base a little bit better.
But I think the interesting part to me is I'm no data scientist, surely. Far from it, right? Right, that's right. But we're practitioners. And so the interesting thing about a tool like Kmeans clustering is it sounds complicated and whatever else. But the reality is this has reached a point of maturity where it's a tool that somebody like you or I as a practitioner can go put to work. Yeah. Like, I don't know how to make a hammer either, but I know how to use a hammer. Same thing.
Yeah, exactly. Exactly how Excel made pivot tables accessible for anyone. K-means clustering with many analytics tooors out there has become really accessible to people like you and I.
Okay, great.
And I'm going to show how it's not really that complicated to do.
Cool.
Maybe a few more steps than doing a pivot table.
Yeah.
So I'm going to talk a little bit about an experience that I've had being director of product design. I've been using K-means clustering to understand our customers and how they use our product better. And that's where I came to the realization, if I was a risk manager or an auditor and I was digging into the product department a little bit, interviewing the director of product design, and he's telling me, oh yeah, our customers behave like this and they use our tool like this, I just have to take his word for it.
Right.
I came to the realization as I've been analyzing our customer data and their behavior that if I was in risk management or I was auditing a product department, I could utilize the same method to validate some of the information I'm getting back from this director of product design who seems to
we're
know
all fundamentally
so much.
risk managers at heart, right? So what you're describing is in your role running our product team, you are looking for you're fundamentally looking for risk that we're building the wrong features.
Exactly.
Or we're building features that won't be consumed. So similarly, this could be applied to any sort of... Well, let's take a look at your example, because I think that's one that we can all relatively straightforwardly understand. And perhaps then we can think about how we might apply it in other kinds of cases.
Sounds good. I apologize. I had to take everything out of the data that could tie it back to any of our customers. So I genericized it, but this is real usage data. And here we have a list of all of our customers from a particular product of ours. And for each feature, I actually skimmed down the number of features to simplify the example. But I picked out
8. How about 8,000 anyway?
Yeah, exactly. I picked out a particular set of features to analyze across these different customers. And the first important step for K-means clustering is normalizing the data. So for each one of these features, I basically had the number of clicks for each one of these features. But one feature might have between 0 and 1,000. Another feature might have between 0 and 10 million. So I had to normalize the data so that they were on the same ranges. Otherwise, K-means clustering gets distorted and gets influenced too much by ranges that are different from each other.
Right.
So to try to simplify as much as possible, I basically turned each data range into a percentage between 0 and 100%, with the max being 100% and the lowest value being 0%.
Yeah. So you're normalizing the Facebook news feed that absolutely everybody uses with data coming back from Facebook Marketplace, which only a few people are starting to use, so that we could get some relative comparison around which clusters of people types, person types use those two different features.
Exactly.
Yeah. Okay.
There's definitely better statistical methods for normalizing data. I took the simple approach here, which I validated with our data scientists is okay.
Yeah. Okay.
So step 1, normalize your data. Step 2, determine the optimum K value. So this is something I didn't mention before. You do have to feed one parameter to the K-means clustering algorithm, and that's the value K, which is the number of clusters.
Yeah. So this sounds really complicated. This is starting to sound complicated. But for a long time, folks in, maybe not so much risk, but folks in audit have been figuring out how to set strata from which they take samples. As an example, is a very similar sort of exercise.
Yeah, that's actually a really good analogy.
Yeah.
The good thing is you don't have to know K up front. You can programmatically find K. So I'm going to show you. I actually used a data visualization. What you do is you run the K-means algorithm on a whole bunch of different values of K. I started with 3 and went up to 10. And then when the variance normalizes, that's when you have your optimal value of K.
And when you say variance, that means how tight the clusters are?
Yeah, it's the distance from the furthest point from your cluster center.
Yes. Okay. Yep.
So I calculated that. I just used addition and subtraction to calculate the distance from the center.
Right. So even if I'm completely non-data inclined, I run this and I just pick the one where the line goes straight.
Yeah, that's pretty much what I do.
Okay. So don't get scared off. Stick with it, and you keep with it, and you'll learn to use machine learning, right?
Yeah, and we can really clearly see here that the data starts to normalize around 6.
Great.
So our algorithm is telling us that we have 6 different clusters or 6 different groups of customers within our data.
In this case, yeah. So around feature usage, there seems to be something that defines 6 different groups that fall into how they use these features.
Exactly.
Yeah.
And you might be thinking,
even though we didn't tell it what that common thing was. We didn't say look by geography or look by industry or whatever. The unsupervised learning figured that out.
Yeah, all we fed it was 9 different fields and a list of customers, and it found 6 different clusters or groupings of customers.
Yeah.
Within
Okay.
there,
Interesting. Yeah.
which I think is really cool.
Super cool.
And
Finding
then,
what we didn't know. Yeah.
so you might be asking yourself, how many steps are there going to be in this? Actually, only 3. We're already there. We normalized our data. We found the optimum value for K. Now we just run our K-means clustering on 6 clusters, and it clusters our data for us. And then the last step is just to interpret the results. And unfortunately, because I had to anonymize the data, and I cut down the number of features to simplify for a short show, it's kind of hard to really tell you what I found, but I have been finding some really interesting things within the data. And then here is a table that shows our different clusters and the centers of those clusters, and we can see that in some of the clusters, like this one, feature 3 was extremely important. This one, feature 4, et cetera, et cetera. And I did do a small data visualization where I just plotted a couple of the features to kind of show you a similar visualization to that clustering we had before. Unfortunately, when you visualize, we can only do 4 features. We can do X, Y, we can do size, and we can do color. And I had to use color for the clusters. But I did find 2 features that did have some clustering in the data visualization, which I also thought was interesting. Feature 9 and feature 4 definitely had some clustering going on. We can see a lot of red over here, which is cluster 4. And cluster 6 came here, and then a lot of purple down in here, and then green kind of has a very heavy feature 9 usage.
So what does that all mean? What did you learn from this in plain English?
In plain English, what I learned is I found different sets of features were being used by different clusters of customers. Right. And now so that was my first aha moment. And now I'm joining that customer data back with customer type and region to see what is creating those clusters. Is it the use case? Is it the location? Is it the industry that the customer is in? And I'm learning more about our customers, which is going to help me inform future roadmap decisions.
Yeah, very interesting. So similarly, if I'm not the head of product design, perhaps I could find in my industry, I could find, maybe I use different data about how, perhaps about, let's say I'm interested in employee engagement. I might use different data, how many hours per week is each employee logged into the network. Let's say if we thought that was an indication of how engaged an employee is, based on
And when are they logged into the
and
network?
when, based on all other attributes of that employee, department, geography, different sorts of demographics, we might be able to cluster and say, where do we tend to engage employees and where do we tend to not engage employees?
Right. Yeah, and you could even look at tenure of employees and try to figure out, is there a relationship between some of those attributes that cluster together and how long we're able to retain our employees.
Yeah. So that's all really interesting. I think it still probably feels a bit complicated. Mm-hmm. I think there is an opportunity for somebody like ACL to help people step through some basic examples, and we're going to do that. But you were using ACL, and not to overly plug ACL, but I imagine those who are ACL customers didn't realize Kmeans clustering machine learning was available as an option there.
Oh, so now you're giving away some product secrets. Yeah, so as part of going down this path, I've been working with the R&D team to actually make put some machine learning algorithms into the ACL scripting language. And so everything you saw there was done using ACL, and I did some scripting around it as well. And yeah, we're building some machine learning algorithms, and we're going to try to make them easy to use and step customers through them.
Right.
And that's going to be
for audit risk and compliance use cases. Yeah.
Yeah. And hoping to deliver that in our upcoming analytics release.
So aside from that being the plug, I think the important part is recognizing, hey, if you do want to go down a machine learning path, you need more than data visualization. Just like, there's these different categories of analytics: rule-based analytics, automation analytics, the statistical and predictive, visualization analytics. This is yet another category. So make sure that as you think about this, you're prepared with the right kind of the right sort of tools and enablement to take that path, because everybody's throwing around the phrases AI and machine learning when it may or may not actually be something that provides a practical solution to something like you were talking about here.
Yeah, and I think K-means clustering is such a useful tool for when you don't know where to start with your data or don't know enough about your data to know where to start. It can start to give you some insights, and then you can start to think about where could there be risk in this data, what are the outliers, what kind of groupings and clusters do we have, and where do we point our resources.
So that's probably the summary lesson for today. If you're looking to both get started with machine learning and similarly looking for a way to get started with data in a way where you don't necessarily know what you're looking for, this is the place to start. We'd surely be happy to hear your questions and provide additional support. Kev, we should probably wrap up there. We've been talking too long and we sound too nerdy. Yeah. But surely if folks would, if you appreciate the video, please subscribe to the channel. Building up our viewership really makes it possible for us to continue this and make it better and better over time. Kev, thanks for the lesson on Machine Learning 101.
Thanks, Dan.
That is some great swag, isn't it?